Welcome everyone to another South African Hack the Box meetup. Unfortunately, or maybe fortunately for you, I can't use my camera due to load shedding, but at least we're keeping it authentic. We're joined tonight by Chris Meister, a frequent guest presenter at this meetup. So if you've been to a few of our meetup events before, you know Chris. And Chris recently switched to a company focusing on blockchain auditing and cybersecurity. And I think whether you subscribe to the philosophy and ethics of cryptocurrencies or not, the security model is definitely quite interesting. And without further ado, welcome, Chris. I'll hand over to you.
Okay, thanks, man. Thanks for that intro. Like Spy Monkey said, I'm gonna just share with you guys once again my experience with getting into the blockchain smart contract auditing side of the InfoSec world. I mean, as he said, you may or you may not agree with what the whole blockchain thing, cryptocurrency, and all that stand for. That's that's beyond the scope of this talk, and I want to share with you guys what I've learned so far, how I got into this. I'm by no definition an expert. I'm very, very, very new with this. So take whatever I'm going to say with a grain of salt. I want to try and spend tonight and just share my experience once again with how I got into the whole blockchain smart contract auditing side of things. At the end, I do want to do like a demonstration that you guys can go or follow with locally. I did share the code that you can download to your local PC if you want to go with me, but I'm going to show it on the screen and just show you like a basic thing of what you can look for. And then hopefully, if everything goes well, by the next time we'll spend the majority of the time just going through like practical examples of how to look for vulnerabilities and all that. Just a quick, if you don't know who I am yet, so I've had to give this introduction so many times over the last while, so I've dumbed it down a bit. Basically, been a hacker since the age of 8. I'm always been interested in security, InfoSec security stuff. So I've been black hat. I've moved over to white hat. So I do ethical hacking. I try and help people. Funny bit of trivia. I remembered this week that I was the 100th human to join Excel. I still have the little badge there to show it. I've done all those certifications. So as you can see, I love the wide variety of stuff that's available to us in the InfoSec community. So I like to learn a bit of everything. You might also think, you've heard me talk about web application pen testing. You've heard me talk about red teaming. You've heard me talk about so many different things, and it's like, am I just jumping around from role to role? And the thing is, my personality type is that I do like change. So currently I'm employed as an offensive security engineer. That's my official title. So at Hellborn, that's the new company that I joined a very, very short while ago. There I do smart contract and bridge that I'll get into a bit later at another talk, auditing. And yeah, I've also been doing some web app pen testing for them. I'll talk a bit more about that. There's the two websites that I either share blog posts on, or you can see my CV. It's a little bit outdated. It speaks more of my development career and all that. And then you can find me just my stern on all social media platforms. I'm mostly active in LinkedIn, where I share stuff there. I'm on Discord, like helping people. So if you want to reach out to me, please do. Just as an example, today alone, I was busy helping someone going through the Basis lab. I was helping someone going through OSWE, and I was helping someone that's busy with the Hellborn CTF stuff. So I like helping people. So please reach out to me. I like learning from that as well. Okay, so how did I get into this? First of all, it sort of came to me. I wasn't out there looking for it. There was a recruiter on LinkedIn, and I've been approached by many recruiters, and I keep on saying to everybody, you know what, I was happy where I was, not looking to move. But this guy was persistent, and I thought, okay, he shares quite cool stuff on LinkedIn. Let me talk. Let me just have a 10-minute discussion with him. In that 10 minutes, he basically like sold this Hellborn company to me. That at the end of that conversation, I was just like, I was committed. I wanted to go and join this company. They sounded cool. They were like doing leading edge stuff. They were, yeah, just did a little bit of research, and it just sounded like a cool place to go and work with. And because I had absolutely no knowledge in the blockchain security section of this industry, I mean, that was a huge challenge for me to go. So again, my OCT kicked in, and I just couldn't say no to this challenge. Obviously, I mean, in this section of the industry, there is a lot of money that's out there that's being invested in all these different type of blockchains and NFTs and all the buzzwords. So there's a lot of money going around. So obviously there's a lot of money to be made. So I will lie if I say that that wasn't a factor. And then anyway, during the conversation, he said to me, okay, if I want to join this company, they've got quite a stringent CTF that I need to get through as part of their onboarding process and technical interview process. So I said, okay, well, how hard can it be? Yeah, those words would come and bite me in the bum. So basically, for the first CTF, I had to go and learn Rust, the programming language, and then also Solana, which is the blockchain similar to Ethereum, which is also the new buzzword, way that they're doing things. So yeah, I need to go learn those two things, do a CTF, and I mean, anybody that's done a CTF will know just by definition, a CTF isn't your run-of-the-mill, do a quick pen test. There's always a trick or something involved with it. So anyway, I decided, okay, I'm going to go and do this. So they've got, if you, they've got on their GitHub page, they've got a section there that I think there's 4 or 5 different CTFs that you can choose. The recruiter advised me to do the Rust and Solana, because Solana is like a new buzzword, try and learn that. So I sat down and I first had to go and learn Rust. Luckily, it wasn't too difficult for me to grasp the basic concepts, because I've been developing since a very early age. I've been a professional developer for a very, very long time. So I see someone's asking if those CTFs are public. They are, yes. You can just go to GitHub, just search for Hellborn there. You'll find the repository there, CTFs. Anyway, so I learned Rust relatively easy in a couple of days. Or I won't say learn it. I mean, I understood the basics, so I could read the source code, understood the vectors and things that was available. Then there's a company or group out there called Neodyme. If you go and search for them, they're quite at the forefront at the moment of the Solana auditing. So they've developed a nice little framework that allows you to, on your local PC, have a smart contract. You can compile it locally. You can let it run locally as if you've got a local net blockchain on your computer, and you can interact with that smart contract. So that obviously makes the auditing process a lot easier, because if you want to quickly test the theory and say, okay, it looks like I can do X with the balance, for example. You can script up something quickly in Rust, or in the POC framework, and you can quickly test your theory and see if that works or not. Instead of because the alternative is that you've got to take your smart contract, which is basically just a little program that runs on top of the blockchain. So the alternative, if you couldn't do this locally, you would need to go find a test net. And a test net is the same as having a complete blockchain. For example, Ethereum, they've got a test net which runs, and they've got people, how can I say, not pretending, but fake mining on there, so that it simulates the real environment for us to be able to test our contracts and programs and things on there. So I know I'm not gonna go into the details of blockchain terminology and that. I'll try and explain as I go along the terms that I think needs explaining. If there is a need, I'm still learning this stuff as well. I can put together a talk at a later stage that deals more with the terminology. But if something doesn't make sense, or you hear me say something, just go and Google it. I'm sure you'll find a lot better definition than I can provide right now. Anyway, so the smart contract, like I said, is basically a little program that you can deploy on the blockchain. And the reason this Solana proof of concept framework works so nicely from Neodyne is that you can do this all locally. So you don't have to go somewhere, upload a contract somewhere, and then interact with it on the live testnet. So this goes a lot quicker, obviously. I had to learn about, like, there's automated audit tools that will, for example, audit Rust, basic Rust vulnerabilities that can occur. Because these smart contracts, they've got their own type of vulnerabilities, but they're also vulnerable to the normal programming bugs and things that we introduce in it ourselves, like integer overflows, etc. So anyway, there's a lot of automated tools that will go through your code, look for these standard type of issues that can arise. For example, are you not checking for errors that can occur in specific functions that are well known to return an error code if there is an error? Are you following standard practices, etc., etc.? And then, but the main thing is you need to be able to read and trace through source code manually. You need to sit and look at code. And I sat and looked at code for days on end, getting frustrated with this. I had to spend my evenings doing this because I'm obviously still working and I didn't want this to interfere with my actual job. So there was just a lot of reading source code and trying to find the vulnerabilities. I eventually did find the vulnerability within the specific smart contract, and that allowed you, okay, I actually can't disclose what it allowed you to do because I don't want to give hints away. But anyway, I was able to eventually find it. I was able to develop a proof of concept, and so I sent it through to them with my report. I had to type up an official report. It's quite nice because they've got a lot of public reports available on their GitHub repository as well, so you can get an idea of the stuff that you need to start looking for, the standard stuff that you can find. But anyway, I sent it through to them. I had my interview. I think I stuffed up the technical interview because there were a couple of questions that I just didn't know the answer to. And I mean, was at that stage, I had known about Solana for about 2.5 weeks. So they were asking quite involved questions about it. So obviously I didn't do my homework properly. Then they said, okay, well, they want me to go ahead and do another CTF just to see, like, was it by pure luck that I found the vulnerabilities and wrote the proof of concepts for the Solana Rust thing, or can I actually learn these things like they were hoping that I am doing? So then I had to go and do audit 2 Solidity contracts that's based on the Ethereum blockchain. So again, I had no knowledge of either. I did help many years ago to develop a cryptocurrency exchange, but that was very basic stuff. I had to interact with wallets and things like that. So that was on a high level. So again, I set, first of all, learning Solidity, which is the basically the programming language that that the smart contracts are developed in, that are deployed on the Ethereum blockchain. So it's for Solidity, there is abundance of information out there. If you go and search on Google, on YouTube, you'll find many like workshops that you can work through, compared to Solana, which you almost find no info for. So again, and Solidity is also the programming language itself, and the way that it's written is a lot more, it was easier for me to read than the Rust, for example. So it's a lot like more traditional, if I can call it that. So then I went to go and learn. Again, there's a nice IDE that Ethereum also provides called Remix. Again, it's a way for you to load your contract in a test environment and interact with it with different accounts in there. And then I also found Ethereum Brownie network, Brownie framework, which I'll actually be demonstrating a bit later. So actually Remix and Brownie I'll be showing a bit later. So those were quite handy for me to test up with again. So my methodology was again the same. I went through all the publicly available audit reports that are available for Solidity, and there are a lot of them. So I made notes of the standard stuff that they found, and then I learned again about the automated tools that you get. There's a lot available for Solidity. At the end of the day, the functionality starts blending in with all the different tools. So there's a couple that you will use actively, but yeah, for the most part, it just checks the standard stuff that you want that will come up. Okay. Then again, I had to read and trace through source code. I set up proof of concepts. These specific ones had more than one vulnerability in there, so there was a couple of different ways to exploit it. So I set up proof of concepts. I went through the code again. I found more. So they do give you a hint in the CTF about the amount of critical vulnerabilities that you can find in the CTFs. Okay, so why get into the whole blockchain auditing section of this industry? If you have a look at the worst ransomware cases that are available, they are a couple of $1 million ransom that needs to be paid. The ransomware groups don't always get their money. I think the effort that goes into finding places to hack, getting into them, deploying the ransomware, I think there's such a long process involved with that. Versus if you go and search for recent vulnerabilities that have been exploited on blockchain, and I think it's in this week or end of last week that there was $100 million exploit that, or funds that were stolen from a smart contract just because of a small little like oversight sort of on the smart contract in the programming that was there. So $100 million for someone that saw something in the code and exploited it. So there's so little effort involved attacking the blockchain smart contracts and that versus ransomware. So I definitely think, and if you follow Rekt News, REKT News, you'll get be updated with all the latest hacks on blockchain. And I mean, it's almost on a daily basis that you'll find that here's 100 million, there's 150 million, here's 50 million that was stolen. So there's just, I think it's definitely going to grow in terms of the amount of funds and things that get stolen. It's relatively new, and it's a growing industry, definitely. There's not many people doing auditing at the moment. yeah, so, and the thing is, the reason I joined Delborn is the guys there they are basically the elite of the blockchain auditors, the smart contract auditors. But I suffer from extreme imposter syndrome every time I sit in a meeting with one of these guys and they explain something to me, and it's like it takes me a whole day to just convince myself, okay, I'm not an imposter. I do actually know how to switch on a PC. So it's like, you know, it's nice working with guys like that. So yeah, they actually, same company is busy with SANS. If you want to get certified, this will get launched soon, SEC for blockchain smart contract security. This Stephen guy is actually one of the owners of Delborn, so he helped develop it. And I see the communications that's going back and forth regarding this. So that's quite exciting that there will be a actual certification also available for this. Just in terms of the options that I've seen just in the short time that I've worked with them, in terms of what you can focus on or what you can, the way to get into this is that, okay, obviously the Solana and the Rust combinations, the Solana being the blockchain and Rust being the programming language that it's done in. So you also use Rust for the exploit framework. Then you've got Substrate and Rust. Substrate is again a custom blockchain that you can build for yourself, the same as Cosmos. So you have all these main blockchains like Bitcoin, Ethereum, Solana, etc., but people can also build their own blockchains to house their own custom needs. So that's quite a bit of the auditing that I'm doing at the moment is with the Cosmos and the Golang stuff. A lot of people use Cosmos as the base for their own blockchain or own bridges rather. And okay, so Ethereum and Solidity I mentioned. What's nice about that is you've got Python that you can use for the exploit framework. For Substrate, you can use Node.js. There's a exploit framework there. And then for this Cosmos and Golang, there's a lot of command line tools available that gets built when you build these bridges and that. So it's quite interesting. And why I wanted to showcase this is there's so many different opportunities for different technology, or not technology, skill set. So if you know Rust, I mean, you'll get into this relatively easily. So okay, so I'm just gonna, before I get into the section about explaining about vulnerabilities and that, I just want to say, I'm not an expert. I'm very, very new in this. I'm still learning. I might have already said stuff that might not be 100% accurate. Do your own research. You're welcome to call me out if I've said anything that's wrong. I'm happy to learn from that. Okay, so first of all, if you have to put together a small little methodology on how you would go about auditing a smart contract, the first thing you obviously need to do, you need to understand the high-level functioning of the contract. That means you need to know what is the purpose of this contract and what functionality does it need to provide to the user. So like I said, this smart contract is just the application that is run on the blockchain. So it's just a piece of code, it's just a piece of software, but it needs to do something, obviously. So you need to understand what it does. So that obviously comes from either reading through the documentation, speaking to the client. Then the first thing to do is to just run some of the automated auditing tools that might just give you some easy wins, or you'll might spot something that leads you to a bit of code that you just need to investigate a bit more to find the proper vulnerability. Then start with the static analysis of the source code. Look for any of the regularly occurring vulnerabilities. So there's things like before an admin function, for example, needs to run. You need to make sure that the person that's calling that function is actually the owner of the smart contract. Then there's stuff like unsafe mathematics, which I'll actually get into a little bit more. There's re-entrancy attacks, which is quite popular, which is a way of intercepting or changing the flow of the contract basically by and introducing your own code into, so it's all like a code injection thing if you have to think about it in like Web 2.0 ways. My aim is to go into each of these things a bit more on the upcoming talks and that, and do it a bit more practical. Obviously, you need to set up a development environment if it's possible on locally. It just makes things so much easier that you don't have to deploy code to a testnet the whole time and interact with something that's not on your PC. You just go. It might not seem like a long time to upload contract, interact with it, make changes, but if you add that over a couple of days, weeks maybe, then that time adds up that you can work a lot quicker if you can do it locally. And then start interacting with the contract. Just test stuff out. I mean, if something allows you to update a balance, for example, see what happens if you put a minus for the value. What happens if you put a large value in a small value? Test different accounts. Can I access someone else's funds, for example? Can I deposit money into a completely different contract that this contract is linked to? So there's endless possibilities. You basically need to think like what a bad guy will think like. I clicked the wrong button here. Yeah, so anyway, so it just comes down to think like a bad guy. What will they try and do? I mean, the main aim is obviously to try and steal funds out of the smart contract. And when I say funds, normally people would deposit money to the smart contract because whatever that will do most likely will have to do with people's funds and buying something or selling something. So there is like a bank account, if you can call it that, that's connected to that smart contract that keeps you the money of the users within in that smart contract or in that account. So the main aim is obviously to try and steal that money. And so yeah, but anyway, my aim is, and hopefully as I'm learning, I could showcase a bit more of these things in the coming years. Okay, so one of the vulnerabilities that I want to talk to you is like, it's called unsafe mathematics. So here at the top where you've got that total bet plus equal message dot value. So that means this came out of a function that's a betting function in casino. So the message dot value is the value that the person is sending to this contract. So if stupid example, I'm sending 1 Ethereum to this contract and I want to add that into my bet. That is what that comes down to. Now the problem is here is if this was a unsigned or assigned integer, for example, in programming terms, that has a maximum value that it can be. And if I just keep on adding values onto this total bet without checking, okay, am I going to reach that programming limit or the memory limit or not? Eventually, I'm going to hit overflow. And I think the best way of describing it is like your speedometer. Once you 99999 and you still carry on and you add something on there, eventually you go back to 0 and it starts all over. So that's a very simplified way of explaining it, but that is what actually happens. And it works. It can work for minus example as well. That you can go back minus, 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 and then eventually you can get back to a very, very big number. So there's obviously ways, if an attacker was able to do this and they can manipulate that message for value without it costing them a lot of money, they can increase their total bet value without spending money. So there's the safe way of doing things, and here the bottom section is you use the safe math that's available. So for this is a solidity contract. So they obviously notice that a lot of developers are making this making this error, because a lot of developers are coming from a non blockchain background. They're getting into blockchain. There's this hype to get smart contracts out. Every developer will know there's always a rush to do things and to cut corners and that. And developers might not understand when they come into this that, okay, there is an issue, for example, with unsigned integers. If I just keep on adding values and minusing values from it. So for them, it's perfectly normal. Let's just add the value in, because in normal circumstances, the worst that's going to happen is the app is going to crash on a local desktop, for example. The person needs to restart it and they can carry on. But with smart contracts, it can actually mean that the money can get lost. People can steal money, for example. So anyway, they've obviously noticed this happens often. So there's a safe math library that you can use. So instead of using plus equal, you'll use a method that's available, that's been extended on that. So that's a simple example there. The next thing, and this is a huge thing, and this is for this is specific, not specifically, but this is from a Solana contract, and there's been a lot of Solana contracts that are vulnerable to something like this. And if you go and look at the Neodyme workshop that I spoke about right at the beginning, they have a funny thing in their slides actually about the whole ownership check. It's such a simple thing that gets overlooked, because again, it's not these smart contracts aren't, it's just normal programs, but I mean, developers wouldn't have to worry about this in a desktop app or even a web app, for example. So what needs to be checked is, so you can see this is a function that says withdraw token restricted. So just by that name of the function alone, you know that this will allow a user to withdraw tokens from that specifically smart contract. Obviously, tokens are what they refer into the currency or the cryptocurrency that you've invested into the smart contract. So you'll deposit, for example, 10 Ethereum, and that 10 Ethereum is the token that they refer to. Excuse me. Okay, so here you can check. All we are checking for is, okay, so at the top here is all the accounts that you provide. So these are all inputs that a user provides. So when I say that, when you interact with a smart contract, or when the website that you visiting interacts with the smart contract, that sends parameters as part of the function calls. So here we'll, for instance, say the vault that keeps the money. We're going to provide that account number of that account info to this function. So we're going to say, we know that this vault is where the money is kept. We know that this is the admin person, this is the config, and this is the vault authority. So I know that's maybe a bit Greek now, but don't worry about that too much. All I want to illustrate here is these are values that are passed from the user. So now the first thing that you need to think about, okay, an attacker can send any value to me. So I need to go and verify the info that I'm getting. I need to go and verify it. So it's the same. If I'm getting an input on a Web 2 application, I need to go and verify it to make sure I'm not going to get an SQL injection if I just plug this in into a SQL query. So it's the same principle here. You need to check whatever the user is sending you to make sure that it's providing you with the correct values, or at least expected values. So here you can see this contract was just checking to see if the admin account that we provided is actually the same account that's in the config. And that's perfect. And then, as you can see, the comment here is then, okay, allow funds to be able to transfer from the vault. But now the problem is we're not checking if this withdrawal token restricted function is being called from the person that actually owns the smart contract. So that's the owner of the smart contract. So we only want the owner of the smart contract to be able to take those funds out of the smart contract. And having said that, that in itself is also an issue that it's called a rug pull if they do it without the users knowing, but we won't get into that. So just what I want you to understand is there's a smart contract on the blockchain. There is an owner that is supposed to run administration functions on that contract. For instance, take the money out that people have invested, or take the fees out that I've earned from people using my smart contract, for example. So I need to be able to do functions like that, but I want to make sure only me, the owner, can do those functions. So let's add in this check, and the correct way would be to check here at the bottom that the owner, the config of this contract, the owner, is what I'm saying it is. So it basically checks there to make sure that the person calling this is the owner of the contract. And the way that works is everything that you interact with on a blockchain happens through transactions, and those transactions will contain your details in as the person sending it. So I'll sign it to say, this is Chris's account that I'm sending this transaction from. I'm interacting with this smart contract, and I'm signing it with my private key that no one else knows, so that when it gets verified on the other side, then we know that, okay, this is the correct person that has sent through the transfer. Okay, I'm going to get to a practical session now. So I don't know if I can get an indication if anybody wants like a 5-minute break. Otherwise, I can go straight into the practical side of things. Everybody is happy, and then I'll. Okay, I'm going to assume that silence means. Okay, let me just quickly get. Just give me a second here. I just need to start. Sorry, when the load shedding picked up my PC, everything closed. Okay. Let's do it. Right. Okay, let's see if that's full. Sorry, okay. So, Jan is asking me if it's on the HTTP domain. Okay, so anybody that wants to follow with, you can go to remix.ethereum.org. This is just a test environment, so you're not going to be interacting with anything live. This is just in fact, you can install this locally as well, which I have in a VM. Okay, if you want to go through there, you're going to need to check on my GitHub. If you want to get the contracts in that, you can come and pull it from here, copy and paste it into Remix. Okay, so, okay, and then, okay, what you'll do is you'll put it here under contracts. And you'll see I've popped it in over there. So then what this allows you to do, quick quick way of just testing a smart contract. So you don't need to compile the thing separately, upload it to the blockchain. This thing takes care of all of that for you in a nice test environment. So if you have it loaded, you can go to the Solidity compiler, you just hit compile. That puts it into bytecode. You'll see it's warning stuff here. Obviously, this is a vulnerable contract, so don't use it. Not that it has any real functionality at this point, obviously. But this is for example, the automated auditing tools and things will warn you about. Use, like it says, unused parameters. The other tools that we use shows you a bit more details and we'll pick up. Okay, so here, this is now the environment that we're going to run the smart contract in, and just leave it on this Java VM, which basically means that just it runs it within the browser. It does everything using your own local resources, and that's why the HTTPS is the issue, because nothing leaves your computer. What you'll see, it gives you a couple of test accounts. These are now the addresses and that you'll have. If you have your own Ethereum account, for example, your account will look similar to that. You'll see it's given each of them 100 Ether, but you can leave all these things as default. What you can do is then you go to the Excel token, which is our contract that we've compiled. If you click on this deploy, the down arrow there, then these are just the parameters that you're going to need to provide. So if you have a look, these correspond to this. This is the constructor. So in development, when this thing starts up, you need to provide it with a couple of parameters that will be associated with it as a smart contract. So what I've just got in here, we'll just call our token Excel, give it a symbol. Then we need to say who the owner of this contract is. Okay. So what I'm going to do, I'm going to take the first one that's over here. I'm going to copy it. I'm going to say this guy is the owner. This address is the owner. And we're just going to give it an initial value. You can put in whatever value you want here. This just basically means this contract is going to have this amount of Excel tokens. So I'm not sure what the conversion rate is for Excel tokens to Bitcoin or Ethereum, but yeah, maybe that's worth a lot of money or it's worth nothing. So anyway, so these are the 4 parameters that we've got set up here. So what you'll see happens here now is we're going to go and mint that amount of coins. So we're going to create those amount of tokens on this contract. And we're going to give the owner of the contract the whole amount. So this is just an array. Here at the top you can see it maps an address to an amount. So that address there for owner is going to be plonked in there, and it's going to give it the amount that this amount. So this is just the array, it's storage that will keep track of who has what balances. So if we have another user, so it will basically store the stuff like this. For example, when user 1 has 100 tokens. So that is the purpose of that. And this only gets run when the contract is deployed. So this only runs at the very start of the creation of the contract. So that is why it's important that the owner is set, so that at the later stage we can actually go and check who is the owner, and we can then confirm, okay, this guy is supposed to be doing administrative functionality, for example. Okay, let's deploy the contract. You'll see here at the bottom it gives some debug output. What you want to look out for is a green tick. That means that it's run through, it's deployed, and here at the bottom you can see that it now shows deployed contracts. And if you open that up, will actually show you all the functionality that's now available. These are the functions that we can run on the contract. So there's a couple of standard stuff that's in there because we've done it as a ERC20 token. It's a type of Ethereum token. So yeah, so we also don't need to go into that. Just know that it is like Dogecoin or any of those contracts. I don't think Dogecoin is ERC20, but just think of that. You can create, and like I said, your own token, Excel token. We've got that loaded now, and you can interact with it. These are like I said, the standard stuff that comes with it. You can transfer, get balances of people. So let's just, for example, go and say total supply. So there you'll see this is the total amount that's available on our contract. So when I hit total supply, you'll see here that a call to the contract. So just interact with it and say get the total supply. If we want to know what the symbol is, click on symbol. It does a call, and this call is what I spoke of earlier, the transaction to the actual network. So if you want to see a bit more what it did, so it went from. So this is the account that we're doing our calls from, which lines up to this first account that I selected here at the top. So that's the person creating the calls to the smart contract at the moment. And he is also the one for every call that you make to a smart contract, you need to pay a small fee, although on the Ethereum network, it's getting quite expensive. And that is why Solana is so popular at the moment, because it's the cost for these calls and transactions are like negligible at the moment. Okay, this is the input that we provided. And there's the decoded input. So it just shows you, okay, we sent a string to HSH to say, the output that we got. So we see no input, but we got output, and this is the decoded output to show that our token is HSH. Now the other thing that we can check, okay, who is the owner of this contract? Let's go. So here you can see it returns that value that we initially entered here when we deployed the contract. So we are now sure we have set the value of the owner of this contract is indeed the one that we supply. And then there's other stuff that you can go and see. We can, for example, if we take the same contract, we just see what the balance is. And then it shows you that person has all the tokens. Okay, so that's just a bit of playing around with the contract, seeing what you can do, what some of the standard functionality is. Now let's look and see what functionality are we providing within this contract. What have we coded in? Okay, so first of all, this is quite a common thing that if I want to set a new owner of a contract. So in the instance like if something happens to the account that was the original owner, I now want to have someone else be the owner, or another one of my accounts be the owner. I want functionality where I can go and set the owner to say, okay, I want to set the owner to this new one. So what I've done is to just make the function simple. This set owner function is going to set this owner storage that we've got here at the top. I'm going to set that to whoever the sender is of that call. So the sender is this person that we select here at the top. Okay, so I want to set, so let's see now. So I want to go, this guy must be the new owner. Okay, so I go here, I click set owner. Then you should notice that there is an error that pops up here. It says ownership assertion, caller is not the owner. So what this has checked is the person doing the call, and remember we now calling it as the second account. This is not the owner of the account. This is just another random account on blockchain. We are trying to set the new owner as that person. So we are now a malicious guy. We've seen this contract as this contract has a set owner function. So we decide, okay, let's see, maybe we can set ourselves as the owner. We do it from that account. That's the attacker. Say set owner. Okay, this guy did a proper job. Now let's look into how did they do that. So what you would notice here with all functions that are public means that anybody can call them. So if you are a developer, you'll know about private and public calls. So if something is set to public, it means anybody can call that set owner function. But then we provide a modifier for it as well to say only owner. So let's have a look. That's code that we introduce. And what this means is when this set owner is called, we automatically call this only owner modifier to do certain checks before we even allow it to get into this function. And obviously it's important that we check that it's only the owner because we don't want just anybody. Because if this was like this, for example, we could run the set owner. Let me just think what else I want to test and then I can actually show you that. Okay, wait, I'm not going to stuff around now with my code just now. The demo gods are against me. Okay, so we are calling the only owner modifier, and here we now checking, okay, is the owner the value that we stored up here, which we saved here when we created the contract? Is that the message sender? So is that the person that's currently calling this function, is that the actual owner? And if it's not, so it's saying that it requires, so this will return a false if that's not the case, and then it won't even get in, it won't execute any of this code. So that's great. This guy done a good job. He's checking to see that only the owner can set a new owner. And if you, I'm not sure if you're gonna notice that yet, but the owner can effectively only set themselves as the owner. And if you want to think about that, I mean, that's obviously not the best function is, but you see, I'm not providing a parameter here like this new owner, and then saying owner is new owner. I'm using the hard-coded value of whoever is calling this address, he is going to be set a new owner. Okay, so there we go. That function works properly. We've got a balance of function here. So all this does, you'll see up, it's an override function that just means it overrides the default method that's already available within this ERC20. So like I said, it provides a number of default things that you can call just because it's an ERC token, ERC20 token, but we can go and override it. So I thought, okay, I'm more clever than the ERC20 developers that developed that whole contract. So I'm going to override and I'm going to create my own balance of function. Okay, let's just do, okay, now I actually already showed you guys that it does work. So what it does, it says the sender is the caller of this function. Okay, I see I made another. Okay. Anyway, so we're just saying the sender of this function is, let's return the balance. What I should have done here is do this. Then I would be able to get the balance of any person. So what I'm saying is I can actually provide anything here and it will just always return my own balance. Okay, that's invalid now. So if we do that, let's actually do that right. Okay, anyway, let me not spend too much time on that. But what I wanted to show here, this function works properly, but I think to look out, that's a red flag, is someone that overrode any of the default functionality that's already available. And I mean, there's people that know a lot better about the specific blockchain and the smart contracts that have written these balance of function, for example. But you always, us developers, always think that we're more clever, So let's write our own thing. And we've actually seen in a live environment in this week where a person decided that the absolute maths function that's provided by the safe math library wasn't sufficient, so they developed their own one, and we actually found a vulnerability within their own implementation of that. So it's always a red flag to just check and make sure. Yeah, the maths is very important in these blockchains because you deal with like precision stuff as well, stuff that's got like 18 decimals, for example. So there's a lot of like mathematical errors that can happen. Okay. Now the other function that we decided we wanted to provide to the owner is we want to adjust the balance, and we want to say this person's balance must be adjusted to this amount. So say there was an error at some point, and we need to now have a function that we can now fix this person's balance basically. So what we need to do is we're going to say, okay, this person here, we haven't used that account yet. Let's go and adjust their balance to 999. Okay, there you can see it went through. Called it, I'm the owner, I called it, I adjusted that guy to 999. Let's just check that. There you can see I put that account in. It returns here, this guy has now 9999. Okay, so with the adjust balance thing works perfectly there. But let's assume that we are an attacker. We've seen here's the adjust balance thing. Let's see, can we go and adjust our own balance, for example? So let's use this very bottom account, copy that over. So I'm going to make the call as this person. I've got his private key and all that. This is my account. I'm going to say, I want to adjust my own balance to whatever. Let's see if that works. We got a successful callback. Let's just check, did it actually work or did it just return? So we put our own address in here, say balances. Okay, so we've managed to basically adjust our own balance here. So what is what happened here? And as you can see, we called it, so we transacted as the attacker. The call came from the attacker, and the attacker was able to adjust his own balance. Okay. So let's look and see what is missing. We know that the set owner thing worked properly because only the owner could basically call this function properly. The adjust balance didn't work. What is wrong there? Yeah. This little modifier that stole the underlying virtual machine that only the owner can call the set owner function is missing from the adjust balance. So in other words, this is not checking at all who is making the current call to the smart contract. So anybody can go and adjust anybody's balance basically. Okay, so the proper thing would have been to have that in there, and then if you call it, you would have gotten that same assertion error as we got here earlier. I don't want to like recompile and everything now, but yeah. So this is what is missing in this contract. Is there perhaps any questions on that? I know it might be a bit much to take in, but I think if you if you understand this small little part, then you can see like the trivial things that are out there that allows people to steal millions of dollars from other people. And this isn't even a case where it's like a completely made up vulnerability. It's a thing that occurs very often in the Solana network, especially. And Solidity, it's been a while already, so there's a lot of like preventative measures against this. But yeah, there's a lot. Yeah, there's a lot of times that just not checking the owner could lead to millions of bands. Okay, I'm gonna assume if no one's asking questions about that. There isn't, like I said, you're welcome to ping me on Discord or wherever. Play around with this. I quite like this. There's other plugins. There's like unit testing that you can involve here. There's like various things that it will tell you that's lacking from the contract, or like even like similar variable names, like standard development practices and things that you can miss out on. Okay, so that's remix. There's a lot that you can do with it. There is, if I find it now, there's lots of other plugins that you can plug in here. You can debug these things as well. So if you again used to development, you can basically step through the functionality. This at the bottom, where was it now? Okay, so if you have a look here, for example, this push 80, push 40, mstore, call value, etc., etc. That's sort of the assembly language for the blockchain VM. Just a bit of extra info. So I mean, this code gets compiled just like normal exe would, or Binex binary, for example, into a sim, and then you can see the assembly and all of that. So it's just, yeah, this is a very nice tool. Like I said, you can install this locally as well. It shows you the storage that's within the contract, and the storage is basically where it stores the database, if you can call it. So obviously it needs to store data somewhere. Okay, so I'm going to stop sharing my screen quickly. I'm going to pull up the next thing I want to show you. So if you have downloaded my repository and you want to open it in Visual Code or something, then we can go through the same thing. This should go quick because it's the exact same contract that we were dealing with now. Okay. See if that's visible. Okay, so exactly the same contract that we've got here. I'll actually just okay, so exactly the same contract, but this is just now in the Brownie framework. And what's nice about this is, again, it's local, and the proof of concepts and things that you're going to be writing is you write it in Python. I'm a lot more familiar with a lot more familiar and comfortable with Python. So all you do is, again, you throw your contract into a specific directory, into the contracts directory, and the scripts is where you'll design your proof of concepts. And then it's as easy as writing the code that will automate the process of what we've just done inside that remix. So I'm going to go through the code. We're going to say, okay, we're going to use the name Excel. This is the symbol, so we'll use HSO this time. This is the amount that you need to use. Yeah, that's the amount of tokens that we want. Then we're going to say, okay, let's go into our main function. This is where it starts. So this is the format that the Brownie uses. We're going to do Brownie run, and then you put the script name, for example, set owner. So that is just that file name that you set there. That will go into the main function first. So we need to deploy our contract, and this Excel token is imported from this name that we've given it here. So it does all that stuff automatically for you. You just need to import it over here, and then we're going to say we're going to deploy it. Again, we're going to provide it with those 4 parameters like we did with Remix. So we again saying the name of this token is Excel, giving it the symbol. We're setting this account as the owner. So again, as Remix gave us a couple of accounts, it's got Ethereum and all that in there already. Brownie does the same. We've got a couple of accounts that's in an array or dictionary. So we're just going to say we're going to use the first one as the owner, and we're going to give it this amount of tokens is what we're starting off with. Then we have to say we are doing this deploy call from accounts, from a specific account. So again, this is the account that's sort of going to be liable for the gas fees and all that. And again, that's going to come into play just now when you check the caller of the function. So we deploy it. Then what we do is that function over there will return for us who is the current owner of that contract. Again, that's the same as on Remix where we clicked on that owner button that's there. That just pulls the value. And you're going to see here we're calling it from account 1. That's just the next account. There's no significance to that. I just made it like that. And now we say, okay, let's try and update the owner. We're going to set owner, but we're going to do it from that account 1. So we know that we set the owner to account 0. So let's see if we are account 1, if we can set that as the new owner. So we're going to run it. You'll see it does a bunch of stuff in the background there. But so excuse me. So for every transaction that happens, it prints out stuff like this for you. So that's basically the transaction ID. So if this happened on a live blockchain, you would be able to go and look up this transaction on the actual Ethereum blockchain. If I can just okay. If there is time at the end, I'll just show you guys how the block explorer and all that works as well. So anyway, this is the transaction ID basically to say this is on the blockchain. This is where you will find this transaction. So the deployment of the contract, you pay for it basically. So it's part of the transaction. This is the address of the contract. So everything has addresses, your accounts that you've got money in, for example, that will have an address. So the contract also has an address like that, and then it will show you, okay, we had the current owner set as that account 1, which turned out to be this. Then we sent the set transaction, set owner function. We sent that transaction. We'll see. And interesting thing to note is even though a transaction failed, you might still pay gas fees for it. Gas is basically the fee that you pay for this transaction to be put onto the blockchain. So you'll see we sent the set owner. We got confirmation that the function tried to run, but here we get that same error message to say caller is not the owner. Okay, and here you can see the gas used. So this failed function you actually still paid for. Okay, so that's cool. We can confirm that that functionality of the set owner is indeed working with this only owner. So let's test our next theory. We're going to pretend to be someone else and try and steal money from or adjust balances rather. So again, we do the same. This is exactly the same. Set the name, symbol, amount. We deploy the contract. Then we first look, what is our current balance? And the section over here. So we'll say balance of account 1, and we're calling it from account 1 as well. Okay, so we're going to check what is our balance. Then we're going to, this is our proof of concept. Let's see, can we adjust our balance by adding 1 million to it? And again, you're going to see we're calling it from account 1, which is the attacker's account. He's the one that's sending the transaction, and he's trying to update his own balance, which he shouldn't be able to do because only the owner should be able to do that. Then just to show the updated balance, we do a call again just to say balance of, let's see if it has updated or not. So to run this, just Brownie run and say steal. so let's look at the output here. Okay, first one would be we deploy the contract. The contract is deployed there. Now we have a look and see what is the balance of the attacker. Let's now try and do the adjust balance for, which is this over here. You'll see it cost the attacker a little bit of money, but he's hopefully updated his balance with 1 million tokens. Let's call that balance again, and you can see we have successfully updated our own balance. So there we can show the client, for example, okay, here we were able to adjust our own balance. Obviously, if this was a proper contract, there would be a withdrawal function, for example, that would allow any person to withdraw their own funds. So the next step here would have been I update my own balance, let me withdraw that money out of the contract. So yeah, this is just, I quite like this because it's easy to script stuff together, test things quickly, and it's also just nice if you get a proof of concept working, that you can send this code to someone for them to run it, to test and verify. Instead of on the Remix, for example, you're going to need to say, click here, do that, do that. So this is just a nice way of like automating that whole process. And okay, so that was that. If there's any questions, you're welcome to ask now. I'm going to say again, you can anytime ping me on Discord or wherever if you're interested in this stuff. Yeah, I'm quite excited about it, just for the fact that it's something new to learn. The stuff that I've seen so far is so interesting. The vulnerability that can come up with, the type of denial of service things that can happen on this with a smart contract. Yeah, I think it just speaks to my personality that within this section of the industry, there's such a vast amount of stuff that you can learn. And yeah, well, if there's no questions or anything, then that is that for me tonight. Thanks for everybody for listening. I'm not sure if Spy Monkey